This is Science 4, and the title of today's presentation is Massless Vector Bosons. What are massless vector bosons? Light particles, photons. The photon has no mass. It has a zero mass. The kind of family that the particle, the photon, belongs to are now called bosons. Actually, they're called gauge bosons. There's another gauge boson that doesn't have any mass. It's called a gluon. There are even 8 different types of gluons. They're little particles that are like light particles, infinitesimally small, and have no mass, zero mass. The gluons were discovered at Daisy in Hamburg, at the big nuclear center there, about 1979. There are 8 varieties of them. The gluons hold together little tiny particles like quarks and hold them. That's why they're called gluons. All they do is they hold. So that what they are interfaces of other things. So you can't think of them as like little couplings that hold two things together. Rather, they are the interfacings which themselves then become noticeable as particles in very rare events. And because they don't exist in terms of some kind of thingness, they have no mass. They have a zero mass. Light, it turns out, also has a very peculiar quality. The photon has zero mass. Yet, it still is, as we would say, operative. It still happens. Light happens. The gluons happen. That gluons happen in 8 varieties and create, in fact, a lattice structure to particality, which then means that there's a fabric to the stuff of the universe. But one can only talk about stuff, one can only talk about things on the level of existence. And part of what we're considering in this education is that reality is deeper than existence. Reality goes deeper than existence. Reality is more profound than things. The ego, the worldly mask, must establish itself, its identity in terms of things. It has to. Things it can pound, things it can touch, things it can see, things it can bank. The persona, the mask, and the ego is just a favorite mask. A very good actor might have a dozen or 24 personas. A good experienced actor can recreate a persona, can recreate a role, and do that ego. It's just inexperienced people have only one ego. And they think that's it. That's me. The coda litany of the ego is me, myself, and I. Sure, I come in versions. Me, myself, and I. And you, well, you're negotiable. We'll get to you later. Whereas the deep self is not an ego and doesn't relate to things. The deep self relates to the mystery of reality and understands that it's zero-based. When you're working in a event horizon that resonates out from zero, then so-called ones are suspended in an infinite matrix of openness. And any one that's there is not just one, but is expressible as one in relationship to the context. So that if one is, pardon the pun, if one is going to be specific, you don't say one as that thing whose identity is itself, one equals one, but any one thing is always in a relational, contextual situation where it's one in the field of zero. So that a form, this form occurs because it's in a space that allows this form to emerge. And so existence is the emergence of one, but the truth of the matter is that without the openness of zero, one would not be able to be definitely one. In art, one calls this the context of form. But the form and its context, because they always have a relationality, that relationality is called, in its expression of movement, a function. So that you have something, but buried within that thing is the array of its functions, and those functions express the relationalities to the zero infinity context, which also is quite real. So that we would then say, in a more sophisticated way, that somebody who is interested in identifying things is on a very low level. They're like in grade school yet. They haven't graduated. And their maturation needs to be led step by step in the grade school of things to where they finally make a connection that all things are within the same context. That context being an infinite zero openness. And so all things have a functional relationality in reality to each other. Which is why the deepest truth about things is their interchangeableness. But because their existence as things, their existential stuff form, has its own peculiar kind of boundary to give it that particular shapedness, that particular action, what is exchangeable is not the whole form, sometimes it is, but most often not, but the center. Centers are exchangeable. This is understandable even on primitive, primordial, tribal level of human beings, because primitive, primordial, tribal level of men and women understand that reciprocity is one of the secrets of greasing the universe so that it works. In the northwest coast, in what is today British Columbia, on the coast, the Indian tribes there understood, the Salish, the Nootka, and so forth, they understood that if you have a massive reciprocity, it means that man is free on a massive scale. And because a lot of their livelihood came from getting into huge dugout boats and going out into the Juan de Fuca Straits and further to go whale hunting. The Nootka Indians used to go whale hunting with antler harpoons. Can you imagine? The Indian tribes in that area understood that massive reciprocity needs to have its own special ceremony. It's called the potlatch, where you give away almost everything you have. Take all of it. But they're not beggared by this because everyone understands the need to constantly do this, so it's always in circulation. And because of the continuousness of reciprocity, the people not only have many things, all of them used to be doing very well, but they also got the reciprocity from the universe, which allowed them the openness of being able to live with little antler harpoons off the biggest fish in the ocean. Pacific Ocean is pretty big. So they were at home in half the planet in a very primitive way. We need today to understand the potlatch in terms of a whole star system, minimally. But a whole star system, a whole stellar system, is not a thing either. It is a one thing in the midst of a universe that's infinitely open and wide all around, and there are many star systems. By gauging a distance in terms of the speed of light, if you went 10 light years in a kind of a sphere around our star, there might be somewhere around 50 star systems. And in fact, those 50 star systems tend to have a kind of a unified movement, as if they were like a family, as if they were like a tribe of stars. And they move almost as if they're kind of like some gestalt form in itself. So now what's a thing? And that star system family, that cluster, has a relationship with maybe another 2 million star clusters very similar to it, some much larger, a few smaller. All of those move on the bow shock wavefront of an arm of the Milky Way galaxy, which itself is yet another form, another oneness. And yet that galaxy is a part of a whole family of galaxies. Now you have to go about 10 million light years out. And in that family of galaxies, there are like about 20 members. And that whole cluster of galaxies, that whole family of galaxies, is moving in such a way that it's approaching a huge, massive cluster of galaxies in Virgo. That cluster of galaxies has maybe 500 to 1,000 members. And all of that has some even larger context. So that when one says you're going to be practical and you're going to be realistic about your education and you're going to count on things you can pound, I say go to hell. Hey, man, what are you talking about? Let's get real. Let's get objective about it. Now, it's taken a long time for men and women to come to the verge of sensitivity so that one can begin to get it. That it's not just what you understand in terms of objectivity, but it's the relational functioning of that objectivity with process. And that process has a kind of a phantom objectivity in itself, like the gluon. The gluon is a particle when you by massive energy collisions, destroy the 2 or 3 or more things that were held together by it, so that instantly, for a nanosecond or a picosecond of a nanosecond, it exists, but quickly evaporates. Where does it go? It goes back into the zero. Which part of the reality of zero is that it lovingly absorbs materia. The way the Taoist energy cycle works is that at the 5th phase, at the phase of the 10,000 things, as they say in Lao Tzu. Lao Tzu says 10, a character for 10, a character for 1,000, and a character for things. Only in terms of 20th century language, you'd have to put some Heideggerian hyphens in there. 10 hyphen, 1,000 hyphen, things. And then you have to put sort of like a parenthesis around that. And you could give that an exponential of 1, so that is itself, and then put that into some other expression. The 10,000 things factor back into the Tao without leaving a trace. Very similar thing happens in deep samadhi when your meditation, when your concentration comes to that still point factors mysteriously back into the world of the 10,000 things without leaving a trace. There's no trace of it whatsoever. Yet, its reality functioning is definitely a dimension. And once you've become conscious of it, you're conscious that that dimension now is operative, though you cannot identify it. And so you learn that it's real because you can't identify it. If you could identify it, it would be another thing. But because its reality is unidentifiable, one then has to shift the whole frame of reference. That reality is not identifiable, but reality is operable. It's what actually happens. So you find jazz musicians in the 40s and beatniks in the 50s and hipsters in the 60s saying, "What's happening, man?" Not who are you or what is this, but what's happening. Because the happening is actually real. It's the occurrence. And the happening includes the functions. It includes the relationalities. It includes the things, and it includes non-things that happen. "2,500 years ago, one of the really masterful concentrators, the historical Buddha, when he would run through a sequence of completeness, he would begin it exactly where you were. He would talk about being seated with arranged robe in this location on a rock, that rock being on a mountainside, and that mountain being a part of this huge range, and that huge range a part of, India used to be called Bharata, Mahabharata, Bharat, and that was a part of something larger, and that something larger, until it included not only the space with all of the stars, but also included the obverse of it, the nothing of it. And that nothing was also included in something far more comprehensive, which was realization, which was enlightenment, which was things and non-things, but not just things and non-things, but the reverse of things and the obverse of non-things. So it always had a 4-part quality, so that one understood that when you were talking about something, what you saw was but a facet of a foldedness. That you could unfold anything to its completeness. So in mathematics today, we talk about a manifold. Its completeness. But a manifold is not only foldedness in space, it's also folded in time. That it occurs in a whole series of time motions. And the first person to ever conceive of talking about things in the completeness of all of its transformations was a philosopher in pre-Socratic Greece, about 500 BC, named Heraclitus. But for him, there was like an honoring of the mystery of nature, and the honoring of the mystery of nature 2,500 years ago was to respect it by not pushing it too much, by not going into it too much. And so he said, you cannot step in the same stream twice. It means that that water is not the stream, but the stream is all that water in its flow. And you cannot step into the same stream twice. The next step in that stream is it's a different stream. If you've ever tried to cross a wild stream that zigzags, you know that the bottom drops out on alternate banks. If you're going to walk on water in a mountain stream, you want to walk in the center of the stream because that's the shallowest part. Otherwise, you're going to plunge. You're going to go into a swimming hole. Heraclitus, saying one cannot step into the same stream twice, this whole thing was pointed out by a French mathematician. His name was Jacques Hadamard. The Psychology of Invention in the Mathematical Field. It's the first edition of his book, published here by Princeton at the end of the Second World War. He was driven out of France by baddies, by the Blue Meanies, and so he was in the United States. And Hadamard is famous. Here's a book on mathematical transformations in chemistry. Fourier, another Frenchman, Hadamard, and David Hilbert, transformations in chemistry. What are transforms? They call them here, transforms. For instance, one finds a mathematical book we've shown before, Fourier series and integral transforms. So that the intelligence about reality includes transformations as a normal part of intelligence all the time. In mathematics, it has for a couple hundred years. What's being taught here is at least 200 years old. So when someone is saying to get with it, to get current, we're just trying to get current with what 200 years ago already was understood. Now, why do you need something like Fourier, Hadamard, Hilbert transforms in chemistry? Because when you're dealing with the stuff of chemistry very often, what happens is that the data that comes to you, the actual stuff that you're working with, the scientific data, the hardcore stuff, comes in the form of not things that you can pound, but of frequencies that appear on electronic instruments. And you have to have a way of taking those frequencies and transforming them into data that you can use in terms of stuff, calibrations in terms of things like mass. So that light not only occurs as photons, as particles of photons, but it also occurs in terms of waves, as frequency. And that in truth, light is both wave and particle at the very same time. It just depends upon you and the operation that you're using, the function that you're emphasizing. It's like light is a switch hitter. It can bat left-handed or right-handed. It just depends on who's pitching. It's a wave or a particle. And its choice of being a wave or a particle is determined gracefully in terms of reciprocity. So men and women have learned by the late 20th century to be very respectful for the mystery of nature by probing deeper. The difference between us and the ancients is the ancients respected the mystery of nature by not probing. We respect nature by probing further. So that we're like on the inside out. We respect nature the same as the ancients respected, but our form of respect is to probe deeper. We know now that Mother Nature then liked her privacy. Admire me, boys. Don't touch. Today she's a lover. She says, the more you touch me, the more I respond. So that you have to learn to be forthcoming, outgoing, explorative in your love for me. And so Mother Nature is like that now. She's a lover, not a mother. So instead of Mother Nature, the future is Lover Nature. She wants us to get involved. And if we do, the universal principle of reciprocity is there. The more that we do so, the more there is to explore. And one says, well, wait a minute. That means that you can never get it, right? No, it means that the process opens out always. So you have to lose the taste of getting it and acquire the more refined taste of doing it, of being there with it. You have to lose the ego's taste to have and bank it and get the spirit's taste of flowing and letting it flow. It's a different taste. The spirit has a differential conscious dimension to it, which opens and opens specifically as a resonance of zero. If zero were not real, there would be no differentiation possible whatsoever. That differentiation happens, that it can occur, is proof positive that zero not only occurs, not only is real, but functions all the time, specifically and especially because it can't be pointed to and pounded. Hadamard, in his appendix number 3, The Invention of Infinitesimal Calculus, goes into some of the history of this. He mentions Heraclitus, that Heraclitus was the first to recognize that instead of pointing to things, you have to gesture to the complete cycle of transformations. A leaf is not just this leaf, but in all of its transformations, its leafness is of interest and is more real. And how, after about 2,000 years, there was a medieval mathematician. His name was Nicholas Oresme. He noticed that in this cycle of from a minimum to a maximum, that all transformations tend to slow down when they get to maximums or when they get to minimums. That instead of transformation being a straight bar of unchangeable stubbornness, that transformations yield to a curve. And that as the curve approaches minimums or maximums, the rate slows down. Now, 600 years ago in France, it's very difficult to open that up further. In fact, a couple of hundred years after that, the great mathematical genius Kepler was the first to realize, because he was a very learned man, he realized that those statements of Erasme applied to the orbits of planets. He was the first human being to be able to mathematically work on the orbits of planets, especially the planet Mars. And he noticed that the orbit of the planet Mars, in its circling around the sun, you have to first get to that stage to understand that the planets go around the star. The Earth is not the center. That's just for openers. But that the orbit of Mars around the sun has an elliptical, it's not circular, it's elliptical, and it has a furthest point and it has a closest point. Perihelion and aphelion. And as the planet in its orbit approaches the maximum point, it slows down slightly, but nevertheless noticeably. And as it approaches its other, the minimum, it also slows down. So that this Heraclitus idea that everything has to be considered in its cycle of transformations, that's what's real about it. The Erasme idea that the rate slows down towards minimums and maximums, Kepler saw that that was true of the universe, of astrophysics. It was true of the planets, and then all of a sudden, in his lifetime, came the discovery from Galileo with his telescope that there are moons that go around the planets. That moon up there is not just the moon, but a moon, that there are other moons. That Jupiter, for instance, had 4 moons that went around it, and they also have elliptical orbits. Minimum and maximum, they slow down. And then Galileo found with his telescope that there were new stars. I don't know how you can imagine to yourself that there was such a thing as a star catalog. Ptolemy in the 3rd century AD in Alexandria made a star catalog. That was it. Those are the stars that we can see. They're fixed. They don't move. They're exactly the same. That's why it's called, and they gave it a biblical term, the firmament. That's God's home. Well, Galileo said, guess what? God is building additions. There are new stars. This whole phenomenon of new stars. Here's a book on the mystery of why night is dark. Darkness at night, a riddle of the universe. Why is the night sky black? Galileo's discovery of hosts of new stars at first alarmed Kepler. He realized what was being discovered here. Notice here that it wasn't that somebody thought there were new stars. Wasn't somebody who theorized that, there should be new stars. But that he observed that, in fact, there are stars that we haven't seen before. And not just a few, there are a lot of them. In fact, what was disconcerting about Galileo, Galileo's little book was called The Starry Messenger. Starry as in incredible multitudes of them. That there aren't just a sprinkle of peculiar, accidental, unique, rare new stars, but that new stars had proliferated so that they dwarfed the number of known stars. And that as far as he could tell, Galileo was trying to be very polite. He didn't want to lose his head. He said, I think if I have more capacity, that I will see ever more stars. Now, we know today that that's the reason why the night sky is dark. The night sky is dark because there are so many trillions of stars and trillions of galaxies of trillions of stars that makes a colossal light in the universe. But that's not really why the night sky is dark. That's not why space looks black. And it isn't really black. It's not like the medieval idea that, well, that's some kind of unpopulated, no-star region, some kind of void. We know now that in the origin of all of those trillions of stars is an improvement on Carl Sagan, trillions and trillions instead of billions. When they exploded out of that pre-pinprick Big Bang presence, that the intensity of light was so startlingly infinite that some 15 to 20 billion years later, when it has expanded and become 15 to 20 billion light years in diameter, in extenso, that the cooling down of that brilliance, that white-hot brilliance, has produced the coolness. It's 3 degrees above absolute zero now, 3 degrees Kelvin. The temperature, the ambient temperature of infinite space, about 3 degrees Kelvin. It means that it's like an afterglow, so that it isn't that it's black, it's that it's super celestial white hot that's cooled down to the deepest tone of dark blue that you can imagine. It's like a flame that has been turned down so that its temperature is just a few fractions above absolute zero, so that the flame's coolness is down into the deep dark blue. When Ed White, American astronaut, performed the first extra-vehicle activity, EVA, and he went out from his Gemini capsule, NASA edited the transcripts. I had a friend who was very close to Ed White. He said it was unbelievably gorgeous because it wasn't a dead blackness, that space is a vibrant, infinite velvet something, that its tangibility was spiritual, and that his shock at the loveliness of infinity, of its beauteous invitation to him, was such a shock that he completely lost interest in NASA, in the mission, in the tin can that he was connected to. And when he looked down, his connection to the Gemini capsule was with an umbilical cord on the spacesuit, exactly where the navel would be, where the umbilical cord of birth would be, and it was covered with gold. Real 24-karat gold. That's what NASA used to use. And when he saw this golden umbilical cord and realized he had been born into lover nature and that she was lovely, he didn't want to go back in. In fact, he didn't go back in. He refused every command to return to the capsule. He was not going back in. They pulled him back in reluctantly against his will and edited everything down. We're not going to talk about it, they said. We have a series of missions and schedules, and you are military men on a scientific expedition, we're not going to be talking about lovely beauty of a sexual encounter, that the cosmos is a lover, and she's ready. What does Zorba say? There's one thing God will not forgive: when a woman calls a man to bed and he will not come. So what do you have? You have a neurotic planet that hasn't been to anything further than military orbits for 25 years. It's getting impatient. This kind of startlingness to Kepler produced a mathematical characterization which he could not, in his time, he could not stand to develop any further. He knew that there was something there, and it took another Frenchman named Fermat to finally develop, as Hadamard points out. Fermat realized that when you mathematize this function, this relational function of minimum and maximum, if you set the minimum and maximum at 0, you get an accuracy in your computations, in your mathematics, which is infinitesimal in its reality. You can go to any degree approaching the minimum or maximum with exact accuracy. That when you set 0 as real, as the parentheses of the computational field within which you're working, your mathematics turns out to be infinitely exact and real to any degree. It took only one step, a step which Leibniz and Newton took, to apply that then to the universe, and that developed calculus, the differential calculus. Fermat was mathematical genius. He realized that this process of differentiation, the mathematical operation which gives 0 as a result if the quantity in question was a minimum or maximum, he began to realize that this differentiation process was integration turned inside out. And that just as there's a differential calculus, there must then be an integral calculus. And that was left to Newton and Leibniz to develop that. And so that we have then, together with differentiation and integration, a complete, whole, infinitesimal calculus. It means that we can be exact in the universe of things to infinite degrees of specificity because we base it on a calibration lodged at 0. So if you have a 0 base, your mathematics becomes infinite. But not just infinite, but capable of expressing exactness in finiteness. But you have to learn, it took until the 20th century, it took until around the Second World War to understand that when you're dealing with the vibrations of infinity, and you want to transform those to the calculations of finite stuff, you need to have a special one, which is called renormalization. Don't look at me. It's taught in every university in the world. It's what you do to get degrees in math or physics or astronomy or chemistry or, it's a long list by now. And the last thing on that list is education. Nowhere on this planet, except here, is there an education that factors reality to this degree and presents it consistently. Let's take a break. let's come back to where we were. And right away, we come into a twist because we weren't anywhere that could be identified. We were circulating in an area that was infinite. And so our education acclimates us stage by stage to a new level of being. It's nothing less than a revolution in the way in which our species can be. If you take existence, if you take the ritual level in this universe, things are, because they're the focus and the confluence of processes that overlap and come together, and stuff is really the interpenetration, overlapping of many processes: time, space, color, mass, so forth. If you squeeze stuff, if you squeeze existence like a fruit, what comes out of that is experience. The mind is objective, just like things, just like existence. Symbols are as objective as ritual. Now you squeeze the mind, what comes out of the mind is parallel, similar, but different to what comes out when you squeeze ritual, when you squeeze existence. In our terms, in human terms, if you squeeze ritual, you get mythic language. You get myth. If you squeeze the mind, you get magic language. You get vision. So if you squeeze objectivity from the standpoint of men and women, our species evolved to where we are now, you get two distinct yet parallel and relationally functional languages. You get a language that's good in tribes, and you get a language that's good in meta-tribes. One of the differences between those languages is that the language of the mind, when you squeeze the mind, you get that kind of a language. It's not an existential objectivity that's been squeezed, but it's an essential objectivity. When you squeeze existence, you get a mythic language. When you squeeze essence, you get a magic language, a visionary language. One of the differences between the two is that a mythic language generally is oral and a visionary language is written. Literally, that you see the language. You write it down. One of the great discoveries about mathematics was that the mathematical notation makes a difference. If you have the wrong notation, if you write it in the wrong way, you come to limits that stop you. Whereas the same mathematics written in a superior notation allows you to go even further. For instance, we don't use Sir Isaac Newton's notation in calculus. His calculus was based upon what he called fluxions. He called change, fluxions. The fluctuations. And it's true that later on, when you know better, a written language of fluctuations can be very sophisticated. But in Newton's time, the written notation of change based on fluctuations, sort of like phase-framed photographs of states of things. If you have a whole array of photographs of different states of things, you can get an approximation of movement. Film is so many frames per second. That's approximation of movement. But in fact, on a really sophisticated level, it's not movement, but it's frame flipping. So Sir Isaac Newton's notation of calculus was based on that kind of a thing, fluxions, he called them. Whereas Leibniz's notation was based upon change that was influenced by China. It was a peculiarity, it was a synchronicity of historical circumstance that the 20-year-old Leibniz happened to be in Amsterdam and talking with the wily old wise Spinoza. And Spinoza, who understood a lot of Hasidic mysticism before it really became just popular, understood that God has a very mysterious geometry that's scintillating, like metaphysical fire. And that in order to talk about things and their movement, one had to talk about this kind of seamless mystic fire landscape, which extends to the very mysterious interior of things. In Leibniz, the young Leibniz is a brilliant boy. I mean, he was absolutely a world genius, even at 20. He began to get these insights, these ideas which were like intuitive glints and flashes, and just at the time when he was stewing about this, he ran across a Jesuit translation of the I Ching, the very first one ever made. Translated into a very clumsy in terms of its theological orientation, clumsy in terms of its Latin, but nevertheless, it was a translation of the I Ching. And Leibniz, right away, being universal genius, saw that the pivot that allowed for the changes of the I Ching to happen was that they alternate 0 and 1 as a binary language. So Leibniz's notation of calculus, when it came to understanding 0 as a base for minimums and maximums, as 1 as some kind of limit by which you approach or don't approach, that when you're understanding in terms of zeros and ones and binary logic, that the I Ching gave Leibniz a leg up, and his notation is the notation we use today. His notation is not based upon frame flipping, but upon the flow of motion itself as it actually occurs. Not upon a very fast camera photographing a stream, but upon the movement of the stream itself. So that mathematics after Leibniz and Newton had a kind of a dual characteristic. On the one hand, it was very good at theory of seeing the pictures in the mind and seeing how those frames of pictures flip in the mind. And the other was paying attention to nature itself, so that the characteristic of watching observable phenomena, watching the stream itself, and then learning how to apply your math. Now, this was very difficult to do. The Leibniz observable method is very difficult. It takes such a thing as renormalization on the higher levels. You have to find some way to take the frequency waves and transform them into particle forms which you can nail down and give a figure to. It may be a decimal with 15 figures after it, but that's what it is. If you're going to measure orange light, it's so many 10,000ths of an angstrom. That's what it is. And if you change it a few 10,000ths, the light that you're describing now is not orange, but now it's yellow. The difficulty is that when you're applying a mathematical language of differential consciousness to observable happenings on the very subtle level, the person observing also is a participant in what's happening. And that in the 20th century was stymieing for a long time. If you take it in a Newtonian sense, that you're conceiving it with a very refined mind, and you have this theoretical basis which then you're applying, it's like Einstein. You can do that work in the patent office in Bern, Switzerland, as he did, or in the coffee house afterwards, as he did. You can be a mathematician who works in his study, as Einstein did. But on the other hand, and that's in the Newtonian, flip frame, mathematical application style. And it works pretty well, but it has its limitations. And the more refined you get, the more those limitations become crucial. Because one is having to stand literally on the tiptoes of the mind's objectivity to reach something else. So that symbols are the base, then, for that kind of development. Whereas the other style of that development is where you start with science and you reach back. You start from the observable cosmos, what's actually happening, and on sophisticated levels you have to compute yourself observing it into that. Your consciousness is a dimension of this experiment. The scientific experiment is not squeezed, dried, inorganic, but it's a mystical happening that is exact. It's mystic not because it's not known. 2,500 years ago, that was the respect for Mother Nature. But this is Lover Nature, who now has a mystery because she is known to infinite exactness. It's mysterious because the exactness is infinitesimally there every single time. You would think that there would be some kind of limitation where you would run out of exactness, and you don't. And that's what the mystery is now. She's the mystery of the lover, not the mother. She's the mystery of the involvement, the engagement, infinite. And one of the first minds to conceive of this was a Frenchman, Joseph Louis Comte de Lagrange, about 200 years ago or more. Lagrange now is commemorated in mathematics. Wherever you see an equation with a big L, a capital L in there, it's the Lagrangian. It's a mathematical focus that is quite distinct from things, distinct from stuff. Nothing you can pound. It's real and exact because you can't pound it, because it's too real to be pounded by something as clumsy as a fist. This is feeble in terms of stuff, not just because of its lack of strength. How are you going to push a mountain? How are you going to push a star system? You want to push the galaxy? Wave your hand. Shout at it. You see? it's nonsense. It's total nonsense. The scale is nonsense. And to insist upon that stuff has to be poundable is stupidity. It's a dead end. In terms of the evolution of our species, clinging to that is an electrocution death. Anyone in the next generation who clings to that kind of practicality is already a zombie, the living dead. Because lover nature is taking life, energy, and giving it only to those who have moved on. She wants suitors, not true believers. She wants lovers of wisdom, not those who are able to pound doctrines. So that this whole quality of what's real, of being practical, of being objective, has shifted, and not just shifted a notch, it's shifted not even just a frame of reference, but it's shifted completely into something more real, which minimally is a conscious time-space, minimally, and several orders beyond that. So that when you're looking at, if you're looking at the way in which modern science operates in its visionary magic language, its visionary magic language talks now about, let's say, an area of concern that's known as quantum field theory, QFT, quantum field theory. The tapestry of reality, not only in its quanta, its thingness, but things which are now Lagrangians. They're focuses that are already factored into the movement function relationalities. So that part of the definition of them is not the outline of their form, but the relationality of their functional context. It's like saying that the figure of this ballerina is not defined by her costume, but it's defined by the ballet in which she is dancing. Giselle is not Giselle because of the costume she's wearing, but because of the ballet in which she performs. So to see someone, if one sees a classic photograph of Plesetskaya dancing and Giselle, one sees then the emphasis is on the costume. But if one goes to a modern performance, a live performance of Giselle, the costume is but one small factor in the ballet. And it's not just when she's dancing, it's the entirety of the ballet. And if you're really aesthetic about it, it's the ballet presented in the house with the whole audience and the orchestra and the knight and your companions. All of that is that ballet. Then you have high art. Then you have high dharma. Then instead of something which you can pound and be certain about, you have a gestalt which is so vibrantly living that you would be embarrassed to pound on anything. You would be beggared to even raise the issue of certainty. It's not certainty at all. The very sign of respect is that one holds in abeyance certainty. And so with the emergence of art, with the emergence of differential forms like art or like the spiritual person, pounding on ritual objectivity is in bad taste. It's very boorish. Because what's real now are vibrant, scintillating gestalts of relationality. And you would be a stupid boor to be pounding on some facet of it and claiming that that's it. So that to a spiritual person, to insist upon them showing their identity card is pretty plebeian, to say the least. Oh, there are very bad words that one could use. I'm afraid they're all true. The bad words applied to them. So that squeezing ritual, one gets a mythic language. Squeezing the mind, one gets a visionary language, which is largely written, so that one reads the language of symbols. And not just visually reads, you can read a visionary language in terms of hearing. You can read by hearing. If you hear the French suites by Bach with a tutored ear, you hear the musical structure. It's there. And one can do it also by movement. One can do it by taste. There are chefs whose meals are appreciated in terms of differential tastes, the combinations, the rare ways in which that taste is there, or the olfactory nerves. All of the senses can be employed in art. And as Wagner was obsessed with, one can try to have all of them together in one master art. Wagner's Ring Cycle is an attempt to have a master art form where everything is together. Sight, sound, texture, smell, all of the senses together in one new kind of art form. And one can even go much, much beyond Wagner. It's very elementary, actually, compared to 21st century art forms. When one squeezes a differential form like the person, one gets not myth and not vision, but one gets history. It isn't that history is made by some static, poundable thing called that guy. Oh, Napoleon. If you pound Napoleon, you get the Napoleonic era. That's not it at all. It's that when you meditate upon, when you livingly squeeze the phenomena of Napoleon's persona, personality, if you squeeze his persona, you get what he said, the myths that he spun about himself. France is the new Rome. All of Napoleon's marshals wore red capes because the legionnaires wore them. Had helmets with a little horsehair crest that went out 1,500 years ago. He brought them back. He said, we're conquering the same territory. Let's look like the old guys. We're back. One of Napoleon's convincing things to his marshals was not that we're conquering new territory. We're taking back what's ours. Do you understand the difference? They took it from us. We're going to go and get it back. That's how you win battles. Not that you're going to beat those guys on their ground, but you're going to beat those guys to get our ground back. He was cheered by the Italians in northern Italy when he won outside of Turin. Why? They said, look at this. Because they had the same myth. The reason he lost in Russia is the Russians were not a part of the Roman Empire. They said, what's this? This is never your ground. When was Moscow a part of the Roman Empire? Which in Russian means wait till winter. If you squeeze a differential form like the spiritual person, What comes out of that is the flow, the juice that is history. History is a juice. It's a spiritual juice that has a flow. So then one asks, all right, we've squeezed ritual and got myth. We've squeezed symbols and got vision. We've squeezed persons and got history. What do you get when you squeeze the cosmos? You get nature. Nature is the juice of the cosmos that's been squeezed. That's why nature is a process and not objective. The cosmos is objective. Absolutely, no doubt. Not in certainty, not in table-pounding certainty, but in the farthest reaches of the gestalts of relational, functioning, proportioned truth. Cosmos is really happening. Objective beyond belief, because its exactness is intensely infinitesimal. 1998, astrophysics can take a single photon from a single star and tell you how much helium is in that star and where it is in its photosphere. Can tell you that the diameter of a neutron star is about 15 kilometers, and that it spins 1,000 times a second, and that there is a magnetic discontinuity on one of the parts of its surface that lets radiation out, and that's why it sends this beam 1,000 times a second, like a cosmic lighthouse, and we can measure that. And we can measure it to the degree that we can tell that some of them slow down to like 999 pulses per second. And that means then that they're not eternally like that, but that they have a life cycle. And that neutron stars in their spin also go through some kind of a cycle. That black holes evaporate and leave little pings outside the periphery called Hawking radiation. It's always paired particles, always. And that given cosmos enough, black holes will evaporate and disappear back into stuff, back into the glorious lover universe stew. So that things come and go, but not only do things come and go, but Lagrangians come and go in a gorgeous tapestry of reality. And that we're able to appreciate that now. We're able to participate, and that somehow, by being conscious on that level, the cosmos reaches out reciprocally to us and like a potlatch gives us everything. Not just spare change, but everything, the whole estate. She says, because you got here and came through that door, through that portal, this is now your house. You're at home everywhere that you can see on every level, and welcome. Not as a visitor, but as an inheritor. 1900 years ago, Apollos of Alexandria in the Epistle to the Hebrews said, what is all this talk about angels? Man is much greater than angels. Angels are messengers of God. Which angel has God ever called a son? Whereas every human being goes through a transformation, is family member, inherits the house, total. Doesn't inherit a chair in heaven, inherits heaven, total. Not like you own it by a deed, but that you're able to live on that wide level anywhere, always. That's called the good news. It's not little good news like not getting a pink slip but getting hiring slip. It's not like that kind of news at all. It's like all the news, instantly, forever. It's a whole different scale. No education on the planet has ever opened this up except esoteric wisdom schools for just the few. The time has come to open those doors, open those windows, take the roof off, kick the walls down, and let that circulate now. Because the whole planet is as small as an esoteric wisdom school used to be 2,500 years ago. That's about it. You used to have to test people 2,500 years ago to see who was able to be worthy of this kind of teaching. Don't throw pearls before swine. Today, people select themselves out with more severity than a wisdom master could ever exercise. They X themselves out by non-participation, by not doing, by not caring, by not persevering, by not getting it that the exactness carries infinitely. You can learn to whatever scale of exactness you require. It'll be there. It is there. So that you inhabit a world exactly as large and as rich as you actually make. That's the reciprocity. Now, expressing this is very difficult. To make an expression of this, to make a language which is able to express this is very difficult. A language like I use, which has a poetic rhetoric, which is sort of post-Wallace Stevens, William Butler Yeats, with a little bit of E.E. Cummings thrown in. This kind of rhetorical language is new. That's why if you play a tape of this for almost anyone, it doesn't matter how intelligent they are, how sophisticated they are, how realized or ascended they are, they won't hear anything. It takes a while to acclimate, because no ear has heard it before. It's new language, completely new. It's a sociological parlance that has a lot of affinity to highfalutin mathematics that has only in the last half century become understandable. And even then, it became understandable in such ways that it was not believed. It was doubted by people who were used to the page frame flipping, Isaac Newton style of notation. They sort of got it, but they didn't believe it. The emphasis is that the theory, from standing on the mind, has its limitations structurally, and where it ends is in history. In the historical process is as far as you can go with the mind. Philosophy of history is as far as you can go by basing yourself and holding the mind so that the mind form remains intact. The more you go into science, the more you go into the cosmos, the more you have to give up the mind. To the extent that you're able to give up the mind, to that extent the cosmos becomes objective. The Zen saying, the Zen realm is a no-mind realm. Not a no-brainer, not by any means, a no-mind realm. And that when you are there in the cosmos, you are there in the cosmos in an observable way, like a scientific experiment that's actually in the Leibnizian style, the Kepler style. One's looking at what is actually occurring and reaching back to try to artistically find the mathematics, the language, the written expression that then can talk this way. And one of the geniuses In the middle of the 20th century, who did this was Richard Feynman. Feynman, who characteristically did not know either the Newtonian or the Leibnizian notation, but had to make his own kind of notation to make it clear to himself. He developed what were called Feynman diagrams, which more and more are being used rather than Newton or Leibniz. One is using Feynman diagrams because they were the squiggles that a self-taught genius used to make sense to him what he was reading, what he was getting to. This is a page out of QED, Quantum Electrodynamics, because one of our books that we're using is Feynman's Quantum QED, Quantum Electrodynamics. It's one of our textbooks. QED and the men who made it. Here's a couple of paragraphs just to let you get the flavor of how sometimes lover nature whispers to someone in particular, the most unlikely imaginable person. She whispered to a high school student in Far Rockaway, a part of New York City that's pretty far away. Richard Dick Phillips Feynman was born May 11th, 1918. A younger brother, born when Feynman was 4 or 5, died shortly after birth. And then it goes on. Far Rockaway, he was a senior in high school. Feynman's mathematical talents manifested themselves early. Many things seemed obvious to him. Having learnt the meaning of an exponent as a high school freshman, it was intuitively clear to him that if the solution of 2x equals what? Equals 32. So what is x? If 2 to the x is 32, how many times 2 do you have to go? You have to go 5. 2 times 2 times 2 times 2 times 2. It's 32. He could look at 2 to the x equals 32, and he would immediately know it was 5. Immediately. It's like Mozart. He had perfect hearing. Feynman had perfect mental symbol. Exact. As a sophomore, we're talking about high school. As a sophomore in 1933, he worked hard on the problem of the trisection of an angle. Divide an angle into 3 equal parts with only a compass and a ruler. And then he had fantasies while he was doing this that there's going to be this acclaim that he would receive upon solving the problem. It's a universal myth. When I was about 11 years old, I realized that sometimes when I was doing something right, that there was like an infinite line of men behind me who had done variations of that, and it was only because of all those variations that I was doing this right this time. I'd look around when I was a kid and didn't realize that it was like all of the possibilities were there instantly in that activity. It's a yogic thing. So here's Feynman. During that same year, 1933, Feynman taught himself trigonometry. He taught himself trigonometry, advanced algebra, infinite series, analytic geometry, and the differential and integral calculus, all at the same time. He taught himself. His progress in teaching himself was recorded in notebooks, which still exist. They're still there. You can go and see them in Caltech, which he kept at the time. What is noteworthy about their content is the thoroughness and the practical bent they display. Feynman was not content to master the formal theoretical aspects of trigonometry. His notes contain a table of the sines, cosines, and tangents from 0 degrees to 90 degrees in 5-degree steps that he computed himself by various ingenious schemes. He didn't know the mathematical standard derivations, so he made up ones for himself. And because he made them up, he had to do his own notations. So at the origin of Feynman diagrams come from his high school explosive intuition of teaching himself higher math. He didn't know the Newtonian or the Leibnizian, ways of writing these magic languages, these visionary symbolic languages. He made up his own. He literally resolved the notation problem himself, did it all himself. So that later when he grew up, became a really powerful mathematician at the early age of 22, was at Los Alamos when they were developing the atomic bomb. He was the mathematical genius because he could figure out things that no one knew, because he knew how to work from scratch and make your own notation. And only later, when the experiments needed some kind of math to express them, nobody had ever done these experiments, so nobody ever knew the math. There wasn't any theory for them whatsoever. And in fact, it turns out in that kind of higher math, there's no way to form pictures of it. So people who were picture-based were crippled. You can't form pictures of the quantum universe. Nothing registers. Why? Because you're dealing with functional relationalities that never are in any identifiable way. There are always these phantom gestalts that can't be pictured. So Feynman developed his own Feynman diagrams to express, to show in a language form what's happening. All these are in notebooks, the beginnings of these things. So similarly, in mastering of the calculus is recorded in a special notebook, a green scribble-in book, marked on the cover, The Calculus, and given the title, The Calculus for the Practical Man. As a sophomore in high school. Which contains extensive tables of integrals that Feynman himself had worked out. Already then, he exhibited the need to recast what he had learned in his own language. And this is like a paradigm. Understanding Feynman diagrams for nuclear physics is something that's now taught in every university in the world that deals with them. They don't use Newton. They don't use Leibniz. They rarely use things from any previous time. They use something like Feynman diagrams. And it's a misnomer. The diagrams are little squiggles, but the squiggles are not intelligible in the sense that they correspond to any things. The correspondences are not poundable. They're apprehendable only by a taste for open, free process relationality. So when you see photographs of Feynman looking like wild genius in physics lectures, that's how he was. The wildness was a part of the reality. He would play bongo drums at Caltech faculty meetings to keep loose. Because you had to be loose in order to see what was exactly there that theory missaw every single time because it used cookie-cutter eyes. You have to take those eyes out. You have to look with something else. So that when you look at the cosmos with no mind, what you see are no walls at all. Nowhere. There are no limitations whatsoever. There are no little colored areas that say this part is Germany, this part is France, this part is human, this part is alien. There are no dividing lines whatsoever. What it shows is a differentiated infinity that is free, that is home to us completely. More next week.